All right, we're going to do the factor theorem, and we're going to graph polynomial functions. Now, I know we've graphed polynomial functions in the past, like a trinomial, for instance. We've graphed y equals x squared plus, well, we can just look at the one we've got down below here. That'd be perfect. This guy here, this y equals x squared plus 3x plus 2. But we're looking more at examples like this, where you'll notice the degree is a power of 3, and in grade 12 you go up to power of 4, power of 5, that kind of stuff. So we're going to figure out and learn what the factor theorem is first, because it becomes really useful, because the only things that we understand or know how to solve or factor right now are polynomials up to a power of 2. So we use this factor theorem, and there's another thing you'll learn in grade 12 called the remainder theorem, and they're the exact same thing. Don't let anybody tell you any different. It's just that the factor theorem, essentially you plug in a number into x, and if that x value makes your y equal to 0, that x value is an x-intercept, which gives you a factor. The remainder theorem says almost the exact same thing. If you plug in an x, whatever number y is equal to, that's the remainder when you divide it out. So if you had a 0, essentially your remainder would be 0. But there is no remainder. We understand that when we long divide. Okay, so you'll hear that in grade 12. We won't talk about that right now because everything works out. So the factor theorem, again, we use it when we want to find an x-intercept or a factor that we can reduce or divide out of a polynomial so that we can continue to factor that polynomial. And you might use it 2-3 times in a single question. So I'll show you how it works. And then we won't actually graph this first example. We'll just use the factor theorem on it, okay? So if I go and I think about this, okay, I'm going to try x equals 0. That's where I start. Well, what does my y equal? And let's get this real straight, real quick. That whenever x equals 0, that's my y-intercept, right? This is going to be my y-intercept for sure. And I always start with this one. So if I plug an x as 0 into there, I get 0. Plus 3 times 0 is 0. Plus 2 is 2. So my y-intercept is 2. But because the y did not equal 0, I know that x equals 0 is not an x-intercept. It's not a factor. I can't get a factor out of it. It's not an x-intercept. So I keep going. So I try x equals 1. And I do this until I get y equal to have y equals 0. Now, we understand that x squared plus 3x plus 2 is a trinomial easy. We could go and factor it normally, but I'm just showing you how the factor theorem works. So if I plug in x equals 1, I get 1 plus 3 is 4 plus 2 is 6. Doesn't work, right? Because y equaled 6. Okay. That just means we keep going. So now I go x equals -1. So what does that equal? Y equals -1 squared is 1. Minus 3 is -2. Plus 2 is 0. Oh, perfect. So what that tells me is, therefore, x plus 1, as you can see if I add 1, to both sides, I get x plus 1 equals 0 is a factor. And you could keep doing that until you got your other factor, or you could divide it out, or whatever you wanted, okay? So this is super important. This is the idea. You want to plug in x values until y equals 0. And once you do that, then you can carry on. And I'm not going to do this question until it's done, because we just wanted to see that this works. Now, you can see if I factor this, I get y equals x plus 1, x plus 2. It's not a crazy trinomial easy or anything like that. So there it is. So you can see that x plus 1 is a factor, and if we were to divide it out, we get x plus 2. So we'll see that on the next two examples here, and then we'll graph them as well. All right, so I put the steps on the side here. So finding y-intercept, that's the first thing I always do. So I just go y equals. Because in mental math, I just plug x is 0 into this question. So x is 0 there, 0 there, 0 there. I get y equals 6. So there's my y-intercept. Perfect. There's step 1 done. Now I'm going to use the factor theorem to find a factor of this big polynomial. So I always start with x equals 1. I actually started with x equals 0, but that's just a y-intercept. That's by default. So if your y-intercept was 0, then that's an x-intercept as well. So I plug in x is 1. I want to see what y is equal to. So I'm just doing this in my head. So I get 1 minus 2 is negative 1. Negative 1 minus 5 is negative 6 plus 6 is 0. So check. That one's an x-intercept. So perfect. So I'm going to square that off as an intercept because we're going to need that. So the factor from that, though, is x minus 1, right? Because if I minus that 1 over, that's the factor. You'll notice it says divide out that factor. So I'm going to divide that factor out of all of this guy. X cubed minus 2x squared. This is a grade 10 outcome, long division. 5x plus 6. Okay, so now I divide out my leading terms. So x cubed divided by x is x squared. Multiply that down through everything. I get x cubed minus x squared. Subtract with brackets. That becomes, the x cubed cancel. That becomes a plus x squared. So negative 2 plus 1 is negative x squared. Bring down the negative 5x. Divide my leading terms again. I get negative x. Multiply it down. I get negative x squared. Surprise, surprise. Plus x. Subtract again with brackets. I get negative 6x. Bring down the 6. Divide my leading terms again. I get minus 6. Multiply it down. And you'll learn another type of division next year called synthetic division. And it's way slicker than this, which is nice. Okay, so we found the y-intercept. We used the factor theorem, found the factor. We divided the factor out. Now we have to factor the remaining polynomial. This x squared minus x minus 6. And that's going to give us our other x-intercept. So I'll do that right here below the steps here. So it's trinomial easy. So I get x minus 3, x plus 2. And remember, that's what our other factors are. So I can take that these are the factors. So then, therefore, by default, I'll put them right over here. I'll just say the x-intercept then from that first factor has got to be x equals 3, right? Because it's x minus 3 equals 0 as well. And then from that last one, the x plus 2, x would equal negative 2. So there's that one. So there's all of our points. Now, if you were to write this whole question out, the other way we could write this question out is y equals, in completely factored form, because we've factored it completely now, it looks like this. And x plus 2. And we know that for an x-intercept, y would equal 0. So we fluked out and got x equals 1 for y equals 0. If you would have missed that one and jumped straight to negative 2, you'd plug a negative 2 in, y would equal 0. You could plug in a 3 and y would equal 0. And that's the idea, is you could essentially keep doing the factor theorem until you got all your x-intercepts, but it's kind of a long, drawn-out process. So now what we can do is we'll go and plot all these points. I kept the steps there for some reason, but whatever. Okay, so let's go and try and draw a graph here. Okay, so up at y equals 6, we got 1, 2, 3, 4, 5, 6. We have a y-intercept. Maybe I'll do that in red. At y equals 6, we have an intercept. We also had 1, 3, and negative 2. So x is 1, 3, and negative 2. Now, what we don't talk a whole bunch about in grade 11 is on these cubics, you'll notice that our a value, I'm going to put an a here. This is our a value. Our a value is positive 1 in front of that x cubed. That tells me that this graph ends going uphill, like so. So it goes through the x-intercept, up like this, and all of our graphs have this nice little end shape like so. So there's our graph. Now you can label your points if you wanted, and the whole works. So if it was negative, if our graph was negative, it would end going down this way. I don't generally do a whole bunch of those in grade 11 because you see that end behavior stuff in grade 12 a whole bunch. But you can think about parabolas and stuff like that. They all have the same rules. Okay, so let's go and do the next example here, and hopefully you see it. There's one other trick that's going to pop up in this next example. So here it is. Again, let's go write our y-intercept, because I'm starting with x equals 0, which by default is our y-intercept. I plug in x is 0, and I get y equals 16. So there's our y-intercept. Beautiful. We need that point. Now let's go do another one. So I try x is 1. Doesn't work. I try x is negative 1. Doesn't work. I try x is 2. Now I'm going to go and do this a little bit different. So I try x is 2. I get 8 minus 24 plus 16. That equals 0. So x equals 2 works. Beautiful. So now that means my factor is x minus 2, which I will divide out of my polynomial, x cubed plus 0x squared, because we've got to have it in descending order of power. I like to put those zeros in so I don't forget about them, plus 16. Divided out, I get x squared. Multiply that down, x cubed minus 2x squared. Subtract with brackets. 0 plus 2 is 2x squared. Bring down the negative 12x plus 2x. When I divide my leading term again, multiply it down. 2x squared minus 4x. Subtract with brackets. Minus 8x. And because you used the factor theorem, you know that the remainder has to be 0. It's going to work out without even a doubt in your mind. So minus 8, I get minus 8x plus 16. If it didn't work out, that means you did something wrong. Either you did your long division wrong, or you used the factor theorem wrong, and when we plugged x equals 2 in, you did that wrong. Something went wrong, okay? Anyways, let's go and factor this trinomial easy. In my head here, I'll just quickly go x plus 4, x minus 2. So there's the two factors. And I noticed something here. We already had, if you notice, an x minus 2 here. But now when we factor this trinomial, we get another x minus 2. So that's going to create something cool here. So from the first one, I know I get x minus 4. But now I also have to remember that I had x minus 2 twice. So this guy right here, we actually write, I'm going to write it in green here. This has a multiplicity of 2, because there's 2 of them, which creates a bounce. Now, as you go up from 2, like if you had 3 of the same terms, that creates what's called a flattening, things like that. And there's a whole bunch of rules we talk about in grade 12, okay, that happens. So this is kind of a neat thing that's going to occur here. So we've got a y-intercept 16, x-intercept of 2, that's a bounce, so it's literally like a ball bouncing on the floor, and x equals negative 4. So let's go graph this guy now. So I'll try to graph this with all the expertise of a professional grapher. All right, so I'll do it in red again. There's 16 magically. Bingo. We got x is 2 and negative 4. Whoops. Negative 2. What did I say? 2 and negative 4. So 2 and negative 4, like this. Again, if you notice your a value is positive, so that's good, positive 1. So that means we're ending up here again. I come down to this 2, and remember, there's a bounce there, so it literally just bounces, goes up, hits that, goes down, and through our next intercept. So you got to watch for those bounces. That was the cool part of this example, okay? So there was a bounce at x equals 2, and it literally bounces there. And if you had a flattening, I'll show you what that kind of looks like. If you had a flattening of power of 3 or something, it might look something like that and still go. If you had a power of 4, and I'll extend this, if you had a power of 4, it kind of just does a whole parabola. It goes flatten out and then keep going back down. So it depends on if your exponent's odd or even in terms of how many you would have. So let's write this one out in factored form as well. Y equals x minus 2 squared. There's our multiplicity of 2. X plus 4. Like so. And that's in factored form.